Okay. Yesterday we have seen variables, static keyword, right, access modifiers, these things. But in access modifiers, we're learning right one thing, right? In the last discussion, what we have seen, right? Default. What is the difference between default and protected? There is a difference, but last class we have seen Y only, both Y only we have seen because we have taken an example of same class, same package. Right, same class, same package, we can access both. Right, in the same class, same package, we can access default and protected. But here we have to see in interview perspective, what is the difference between default and protected. Right, the same class we can access, same package we can access, other package we cannot access. But what is the difference is other package, right, subclass, right. Other package, we have a class. There we can access protected variable, but default variable we cannot access. Right. In the last class, what we have seen, where is that we have created. Right. In the last class, I think we have seen in the same package. Parent we have taken, child we have taken. We are able to access default protected public all. But actually, we have to see at the same class in other package. Basically, we have to see with the other package. Suppose I just let me copy conditions package. Okay, same class. I will copy child, keep it in the right here. Okay, now first import it. Right, first we have to import it because this is both are in different packages. Both are in different package. We have to import it. Now, right, if you see default one, we cannot access. Right, a default variable of one package with in other package we cannot extend. We cannot access even if we extend also. If we make it as a right subclass also, we cannot access that default variable. Default variables are default methods. Right. But in same package, we can access. If it is the same package, we don't have any restriction. But if it is in other package, employee is in one package, child is in one package, but still employee related default variables I cannot access in the child because both are belongs to different packages. Right. This is the interview what they will expect. What is the difference between default and protected? Right. Yesterday we have seen same package. Same package we can access, but other package subclass we cannot access. This is the difference we have to explain when interview asks. Right. That is one thing I want to clarify. Right. Now we will move to final. Right. A final keyword. Right. What is the final keyword? Right. What is the final keyword? Right. Final is just a keyword. Right. We will use for three places. Actually, we will use it at three places. Right. We will variable level. Right. We will use at variable level, method level, and class level. At variable level, method level, class level. We can use it these three places: variable, method, class. But directly we will go to right example so that we'll get more understanding. Right, let me create a package. Okay, fine then. We'll create class maybe student. Right, fine. Student name is student ID. Okay, fine. Right, and also we'll create private. Right, private static string to school. Right, school. Okay. Yesterday, what we have learned? Static keyword. If we create a static keyword, memory will be created only once. It is belongs to class. So every student can access it. Right. Every student. There is a drawback. What we have seen. Drawback is what if any one student. Right. If any one student updated school name, it will affect to all the students. Right. Suppose it will create a student. Let me student one will create a student. Okay. Suppose student one is right. By using object also we can access these data static variables, but that is not the correct way. But suppose student one dot school name is changed to something at xyz. Right, xyz. Now suppose student two is trying to access. Student two is trying to access the school name. Student two dot school name. Right, if I run it, let's see. Previously what it is ABC high school. Right. Someone is by mistakenly or intentionally is updated. Right. It is affected to all other students. Right. All other students. Right. To avoid this is the not correct way of accessing, but there is a possibility. Right. So to avoid that problem. Right. I don't want to allow anyone to change it. Then we can make it as a final way. So that what will happen? Okay. Let me. Right. Final variable. Now what will happen if anyone try to modify it, right? Immediately, right? They will not able to modify it. Immediately they will get right. They cannot assign any value to this final variable, right? Final variables cannot be modified. Final cannot be modified. Right? Usually final we will use at constant variables. That means fixed values. Right? I have a fixed value school name. I don't want to allow anyone to modify it. Then we will use a final. Both we will use because without object we can call this school name and final will restrict to the modification of it. Right. These are all called constants. Whenever you have constants like the fixed constants. Right. Like whenever you are automating your URL, username, passwords. Right. Some of the text label text if you want to validate. Those are all we will take it as a constants, private static final variables, right? So that no one can allow to modify. Right, that is the one thing. Final at variable level, we cannot modify it. Final at method level, right? Final at method level. What it will do? Suppose I will take a sorry. Let me create a child class. Child class extends student. Okay. Right. If we have a constructor, see, if we have a constructor in the parent class, see, we don't have default constructor, only private constructor is there. Now, if we try to extend student, right, it is asking implicit super constructor student undefined for default constructor must be explicitly. If you, what will happen here, concept is, right, if you don't have constructor, JVM will provide a default. But here the problem is we have created right parameterized constructor. Parameterized constructor. So what is happening? Child is unable to call default constructor. Right. In the constructor topic, right? We can also have a one more thing, right? Whenever, suppose I will tell you first that one, right? Later will come here, right? If I have a default constructor, default constructor means just register default constructor, right? Now if we extend C, there is no error, because what will happen here in this case, whenever we create the whenever we create the child class object, right? We'll see example. This is also one more interview question, we can get it, right? Fine. Well, we'll make it as a okay, student class default constructor call. Okay, now child with okay test. Now I am creating the object of the child. Right. I am creating the object of a child. Right. Now what will happen if I run it? See, student class default constructor is called automatically. Right. I did not call anywhere. How it is called? Whenever we are creating the child class, what will happen? There is no default constructor. So JVM will create it, and also it will call the parent class constructor also by default. Parent class default constructor it will call automatically. Right. If you create it, suppose default constructor, right? If you create the default constructor, right? Okay, now we'll make it as a one, right? Child class default constructor code. Let me execute it again. Now, first, what is happening? Whenever we are trying to create the object of it, default constructor of the child class will call automatically. It will call parent class default constructor. Parent class default constructor. That's why, right? That's why we are seeing first parent class constructor is executed, then child class. Right. Internally, what happened is there is a one super class will call automatically. Right. This will inject by JVM automatically whenever class file is generated. Right. That's why from the child class constructor to parent class default constructor automatically called. Suppose if I don't have default constructor in the parent, right? Then see it will not allow actually. Implicit super constructor student is undefined must explicitly invoke it. Right. It will not allow. If we that parent class have only parameterized constructor. Parent class has only parameterized constructor. What we have to do? Right. Either we have to call like this default constructor. Right. Default constructor. And we have to call from parameterized constructor superclass. Right. Superclass parameterized constructor we have to call. We will learn in the next topic this one. Right. Just to mix. But our topic is not this one. Right. We will in detail. We will learn later. Our topic is what? Okay. I will make it as a default constructor for now. Okay. We are final at method level. Suppose in parent class, I have a method final get name. Get name is the final. Get name is the final method. Now, what is the inheritance concept? What is the inheritance concept? We can override the parent class methods. Right. Whatever visible methods only. Private cannot be visible. Right. Default with the same package, it will be visible. We can override default methods, protected public methods. Here, what I have done, I make it as a public. Now I try to override it. I am trying to override. Right now, what is happening? See, cannot override final method from student. Right. If we use the final at method level, we cannot override in the child classes. We cannot override in the child class. That means what it is telling, what is the use of it? Parent class restricting the child class to override it, because parent class is restricting. You have to use my functionality only. You should not change the functionality of it. Right. Suppose if we take a right RBI bank, suppose RBI bank is providing some feature, they want to restrict every bank should follow the same standard, same for standard. Then they will restrict it, right? We can use in that case final, so that every child class should use the parent class functionality only. There is no chance of overriding and modifying the functionality of it. Right? Final at method level, we cannot override in the child class. And class level. Class level. Suppose I make it as a student as a final. Student as a final. Now immediately child is extending. What is happening? The child cannot subclass the final class. It cannot subclass it. Right? Final classes cannot subclass. That means we cannot extend it. Right? Final class cannot be subclassed. Right? That means we are restricting the other classes to extend it. They have to create the object of it and use the features. Right? We are restricting. Right? That is. Final at variable level, we cannot modify. Final at variable level, we cannot modify the value. Final at method level, we cannot override in the child classes. Final at class level, we cannot subclass in other classes. Right, those are the three things. Suppose I have created a final variable like this. Okay, static also for now I will remove. Now what it is saying, see, you cannot declare like this final variable, just simply like instance variables. Like instance variable I have created, final variables we cannot simply like this. The value of the field is what it is saying. Okay. What is that? Okay. Let's see. Initialize the final field school name in the constructor. It is asking to initialize. Before using it, we have to initialize. Final variables must be initialized declaration, either at declaration level or in the constructor. But it is a static variable. We cannot initialize in the constructor. Right? Because every object is created, again it will create memory. Right? It will initialize. Right. So how to initialize that? Right. Static will what we have learned? Static block. Right. We have to initialize in the static block. If you want to do like that, we have to do it. Right. Suppose you want to get a school name from the database. Right. Or you want to get from the Excel sheet, JSON files. You want to get from somewhere, you want to initialize it. Then in the static block, we will write a piece of code and we will initialize that school name. Right. In the static block, we have to initialize static variables. Instance variables, we will initialize in the constructor. Right. That is the final variable. Right. Final. Final we can use at the variable method class level. Right. Fine. Next topic. This and super. This and super. Okay. We'll start with the this. We can use this as a keyword or this as a constructor. We can use this as a constructor or a variable. What is this? What is the use of it? This refers to the current class instance. This this refers to the this refers to the current class object. This refers to the current class object. Alright, please mute everyone if you are not talking. Okay, fine. This refers to the current class object. By using this, what we can do? Alright, we can call the current class variables and methods. Variables and methods and constructors. By using this, we can call this refers to current class object, current class reference. Right? By using this key, we can call current class variables, current class methods, current class constructors. Right. Let's see. Alright, see, this is one of the example where we will use this mostly, most of the times. Right. This refers to current class instance variable. Here, why we are using in the constructor? Because this name, local variable name, is same as instance variable name. Right. To differentiate between, I want to assign this local variable to instance variable. Then only, right, object will be allocated memory for this. Suppose if I remove this, what will happen? This name will assign again to same variable only. It will assign local variable to local variable only. Right, there is no change. So I want to assign this local variable to instance variable. That how we will differentiate? By using this keyword, we can different. This means we are referring the instance variable. I am assigning local variable to instance variable. By this keyword is used to refer the current class variables. Right, current class variables. Right, this is the one scenario where we will use this. And also we can call, right, suppose I have a method like public void display, right, display, okay, display data, okay, something. Right, here we can refer direct in the same, right, we can use either this or, right, we can use this keyword to refer the instance variables and also methods. Suppose if I want to call by using this, we can call the, right, get age, right, we can call this dot get name, right, we can call by using this keyword current class variables, current class methods, current class variables, current class methods. But in the same class we don't require, right, in the same class directly we can call. Only this is the scenario where we will use this, right, if this one, if local variables and instance variables are same, to differentiate between this we will use this keyword. Right, that is the only one. But usually this keyword is used to refer the current class variables, current class methods. Then how to call the constructors? Right, I can call from one constructor to another constructor. I can call from one constructor to another constructor. Suppose I want to call from the default constructor to parameterized constructor. How to call? Right, how to call? What I will do, just will remove these things. This this yeah, please mute whoever not speaking. Right. Okay, fine. See, by using right, I want to call from default constructor to parameterized. But here, this always must be a first statement. Right. Constructor call must be a first statement. Right. We cannot write second place, third place. But this keyword we can use anywhere. But constructor call must be a first call. First statement. That means first statement in the anywhere. If you want to, where you will use constructor only. In the constructor only, we will use this to call the constructor. right? It should be always a first. Second statement it will not allow. Right? We can call from default to parameterized or parameterized to default. Suppose if I try to write like this, right? What will happen? When our object is created, it will call the parameterized, again parameterized to default, right? Loop will continue on. We cannot call like this, right? Recursive calls, right? Recursive constructor, it will never end. So it will not allow both at times, right? Either we can do anyway, either one of the way only we can do. Right? We can call from parameterized to default or default to parameterized. Any one way it will allow. Right? This way, by using this, we can call the constructor, current class constructor. And also sometimes I want to return current class object. Right? I want to return current class object. Sometimes, right? I want to current class object. How we will return? Suppose, okay. Here display info. I want to return the current class object. How we will return this. Then what is the return type? Current class. What is the current class? Student. Right. Like similarly integer. We are returning int, return float, return double. Same way. Return. We are returning the current class. Current class. Current class means student. Right. We are returning whoever call this method. Right. Suppose I am calling display info. Right. Student one dot display info. Right. It will return the current class object. That means method chaining we can do. Suppose on this display info, if I want to call one more method, I can call it because it is returning the current class object, right? It is returning object. On that object, we can call again method. But get age is what is calling integer, right? You cannot do again dot, right? We cannot, right? Only object. Whenever we are returning object, we can do the chaining, method chaining. It is called a method chaining. Right, we can return current class object also by using return this. If we want to pass this as an argument, we can also pass. We can also pass argument. Right, suppose the display info is taking a student object. Right, suppose student. Right, then I can call display info with this. It's not allowed. Static context. Right, one more thing. We cannot use the this in the static keyword. Not keyword, static methods or static blocks. We cannot use this in the static methods or static blocks. All right, now we will say, all right, if you want to call this display info, we can call from some other method. All right, display info, pass this, right, current class object. Right, we can also return the current class object. We can also pass to other methods as a argument. There are multiple usages of this. Right. This refers to the current class object, current class reference. Right. By using this, we can call current class variables, current class methods. Right. And also we can call constructor, one constructor from another constructor. Right. This constructor call must be a first statement. Constructor call must be a first statement. And this cannot be used in static, either static methods or static blocks. Right. Static blocks also it will not allow. Right, static methods. In the static context, we cannot use this. The static context, we cannot use the this. Right, that is about the this. Right, that is about the this. Then we'll see super. Right, what is the super? Super class also we will have. Right, super keyword also we have super and constructor call. Both we will have super keyword, constructor call. Right, what super refers? Suppose I have a parent and child. Right, parent and then child. This is the parent and then child. Right. From the child, I can call parent class variables, parent class methods by using super keyword. Right, by using the super keyword, I can call the immediate parent. That means if we have a multi-level, I cannot call top parent variables or methods. Only immediate parent. Right, immediate parent variables and methods I can call. And also by using constructor, I can call from child constructor to parent class constructor. I can call from parent class to child class to parent class constructor. From class constructor to parent class. Right. This refers to current class. Super refers to immediate parent class. Immediate parent class. By using the super keyword, we can call the parent class variable method constructors. Right. Suppose here, mm, this is the child class. Right. Suppose I will write a public void display. Okay. Simple. Right. Now, if I want to call say super class method display info. Right. We have a method in the super class. We can use super dot display info or super dot right. If we have any variables, all are private, right? We will make it one as a public or protected. We can make it. Right. We can call that name super dot name. Right. By using the super keyword, we can call the super class variables, super class methods, and also we can call suppose child class. Right, child class constructor. From the child class constructor, if I want to call the parent class constructor, I can call. If you want to call super also will expect the first statement only, right? It will not allow right second statement. Super also we cannot use in the static context, right? We cannot use both this and super in same because because it will not both constructor try to fight both should be first place only, right? Say any one is possible. I can use the this or super. We cannot use both. Right. Super, by using super, we can call super class default constructor or parameter. If you want to pass the parameters, you have a parameterized constructor, you can call. Or child constructor if you want to call child. Right. That is about the super. Right. Super is used to super refers to the parent class reference. By using super, we can call super class variables, super class methods, super class constructors. We can call. Right. We cannot use super at static. Static context it will not allow. And constructor call must be a first statement. Constructor call must be a first statement. Right, fine. Right. Hmm, that is about the this and super. Any questions so far? Any topic? Any? Okay. No. Fine. We will see. Right. Exception handling we will start tomorrow. Uh, Before that, we'll see string. String a few more concept. Right. Right. Interview question. Right. We will get mostly right on string. We will get mostly one or two questions. Let's suppose I have a string. Okay. Something codes. Right. We can have a string as to equal to codes. Right. This is the literal way of creation. Right. Then also we can also create a string using object. Right. S3 equal to new string, new string. And the string I will assign same thing for Java. This will be a core Java font. Okay, same thing again. We'll create a string S4 equal to new string of red core Java. Okay, fine. Now we have a 4 strings here. Now the questions will be that S1 equal to S2. What will happen? Right, S1 equal to ES3. What will happen? Right, ES3 equal to ES4. What will happen? This is one thing. And then S1 dot equals S2. Right, what will happen? Similarly, string S1 equals to S3. What will happen? And then S3 equals S4. Right, what will happen? Right, in this case, actually, what will happen? Right, usually, whenever we will create a string as a literal, right, we are creating here string as a literal and object. Right, first two S1 and S2 are literal way of creation string. What will happen? It will create a memory, right? It will create a memory in the string constant pool. Right, memory will be created inside a string constant pool. Right, whenever I have created S1, what will happen? S1, it will in string constant pool, it will create the strings. Right now, S1, right, will refer to that course hour. Now, S2, whenever I created one more literal with the same content, what will happen? First, it will verify. Is there any string available in the string constant pool? Yes, if it is available, what will happen? It will point to the same memory location. Same memory location. Same memory location. If I create with a different content, it will create one more literal. Right, but here S1 and S2 have both same content, so it will refer to same memory location. But S3 and S4, these are all object creation. Right, here we are creating like a string as a object creation. Here what will happen? Heap memory. Right, right. In the heap memory, objects will be created in the heap memory. And the heap memory, it will create S3 one memory location, S4 one more. Both will have a different memory locations. Right, both will have different memory locations. Content will be same, but memory locations will be different. Right. Now coming to S1 and S2. Right, S1 and S2. Here, what is the first condition? S1 equal to S2. First of all, we should know double equal what it will do. Right, double equal to what it will do? It will verify the memory locations. It will compare the memory locations, not the content. Double equal to is reference equality. Reference equality means memory locations. It will compare the memory locations. Dot equals means content verification. Dot equals means content verification. Now double equal to, now see S1 and S2. What will happen? Both have same content in the string constant pool. It will point to same memory location. Right, what is the output? It will be a true. Right, S1 and S3. Now S1 and S3. S1 is in different memory location. S3 is in different memory location. Right, both are different memory locations. Then false. S3 and S4 also, it will have a different memory locations. Right, it is also a false. Right, that is also a false. Now come to equals. Equal, what it will do? It will not worry about memory locations. Only content comparison. If both have same content, S1 and S2, right? It will be true. In all the cases, it will be true only because content same for all the strings, right? Double equals means it will verify the content, right? Sorry, equals means it will compare the content of the strings. Double equal to means memory locations. Memory locations. Whenever we will create as a literal, whenever we will create as a literal, it will create in a string constant. Now interview, maybe we can also get one more question. Why it made as a string as made as a, right? What is the behavior? Right? It is a immutable, right? This is called a immutable. Immutable. Immutable means what? Right? String is a immutable class. String is a immutable class. Why immutable class? What is immutability? Suppose if I create one string s1 equal to right something Java. Okay. Now what will happen? In the string constant pool, it will create a one Java. Right. Then it will point s1 to this. Right. Now I have modified s1 dot something concat. Right. Something anything. Right. Hello. Now what will happen? Right. It will create one more memory location. Right. This reference will be gone. It will not update in the same location. Java will be there. In string constant pool, it will be there only. But it will create one more Java hull. Then S1 point to here. Right. Immutability means what? If you modify the string, it will create the new memory every time. Whenever you modify, it will create new memory. Whenever you create, update or anything, if you do any modification, it will not change in the existing location. That's why it is called a immutability. Right? Why it made as a immutability? Suppose if it is not immutability. Suppose it's not immutability. Suppose I have created 10 variables, all are pointing to Java only. Suppose you think I have created 10 variables, all are with string Java, all are pointed to same. Suppose if any one is updated, right? S1 equal to S1 dot concat hello. What will happen if it is not immutable? It will change in the same memory location. Now what will happen? It will reflect to all other strings, right? All other strings. It will impact remaining also, right? That's why Java people made this string literal as a the string as a immutable basically, right? That's why we call it as a immutable. Right, whenever we try to update the string, it will create a new memory location every time. It will not right that is it. It will not modify the existing. It will not disturb actually. Right, right. You got it right. This is the one more important interview questions we can get at downstream. Right, fine. Any questions? Anyone has any questions? Right. Then we'll see in the next class exception handling. Tomorrow we'll connect and we'll see. We'll start with the one more important topic, exception handling. Right. That's it for today. If you don't have any questions, we are good with that.